again, welcome back to the latest lecture session. So, until the previous class, we have been, our session, pardon me, we have been discussing the relevant aspects with respect to remediation of contaminated groundwater, right. So, we looked at different techniques, let us say, passive techniques like permeable, reactive barrier and so on and so forth. Obviously, there are other techniques too, but we looked at or covered those aspects that are most widely used, let us say, right. So, again, depending on the site, you need to choose which condition or which particular method to go for or not, right, and that is something we are done with, let us say. Now, we are going to move on to obviously looking at contaminated soils and sediments, let us say, right. So, in subsurface you are going to have obviously soil and sediment, right, and you are going to have contamination of these soils and sediments too, depending upon the type of spill and also the type of contaminant, right. Obviously, in this particular context we are going to, or for the next half of the relevant class, let us say, we are going to discuss various methods to deal with or remediate contaminated soils and sediments, right. So, in this context, let us look at one quick example. So, the example that we are going to look for or look at, pardon me, is, let us say, we have the case of Moradabad, right, and as some people might be aware of, we have a thriving what do we say, e-waste dismantling sector, let us say, typically unorganized, right. We have huge volumes of e-waste that we are producing, let us say. Again, smartphone, I think nowadays people just throw that away after 2 years maybe, or 1 year, depending upon the model, I guess, right. And so, what happens to this particular what do we say, cell phone that you dispose of, let us say, right. Typically, we are supposed to dispose of that in a scientific manner, but typically we do not do that, right. So, those that are not disposed of in a scientific manner, which what do we say, consist of the majority of what do we say, cases with respect to the disposal, let us say, right. And what do we, where do they end up? They end up with, let us say, these, or end up at these unorganized e-waste dismantling centers. So, if not the cell phones, let us say your computer, what do we say, your CPU units and so on, where you have the PCBs, let us say, and such. So, again you have rare earth metals and these particular what do we say, e-waste, right. And so, obviously, in a country like India, we have I mean where we have considerable unemployment, people obviously look for what do we say, means of survival and income, right. So, there is a thriving what do we say, e-waste what do we say, dismantling economy out there. Again, obviously, it is supposed to be illegal, but again people do look for sources of employment, right. They do not look for typically whether it is legal or illegal, especially when it hits the stomach directly anyway, right. Again, one such particular capital of e-waste what we say dismantling, let us say, is in Moradabad. So, I heard when I visited the site, that I came to know from the relevant people working there that waste from as far away as Tamil Nadu or Andhra Pradesh end up at Moradabad, right. Again, so this is on the along the bed of the river Ram Ganga, okay, Ram Ganga. So, I am going to present some pictures later on, maybe in the next session anyway. So, for now we are going to just look at or have a overview here. So, what do? They more or less you have different what do we say, elements out there, but obviously they want the relevant rare earth or the relevant heavy metals, let us say, right. So, they either segregate that the chips, let us say, and so on, or the circuits or circuit boards, right, and then they pulverize that and then burn that into relevant what do we say, molds, let us say, or balls, if I can say that, and then crush them again, let us say, into smaller pieces or relatively smaller pieces, and then they wash them by hand, so that by gravity they relatively what do we say, heavier compounds, they settle down. Typically, they are your metals, let us say, right. So, obviously, in this process, let us say, they burn these relevant boards. Again, you have dioxins, considerable levels of air pollution and air pollutants are emitted in that particular vicinity. And again, you have, let us say, when you wash this particular powdered material, let us say, you have considerable what do we say, contaminants again leaching out, right. All that wash water that they use, they just let that flow out onto the into the river. But obviously, the river is not perennial, so it typically ends up contaminating the soil or the banks of that particular river, let us say, right. And also you have, let us say, no process is obviously 100% efficient. They tell me that they, as in the people working in Moradabad, let's say, they mentioned that their efficiency ranges from 70 to 90%, but we can never be sure. But again, even after their recovery, let's say, you are going to have considerable concentrations of heavy metals leaching out onto the banks of this relevant river now. So what do we have here? Let's say, I think if this is the river out here, and I think on this section, let's say for 3 or 4 miles by 2 or 4 kilometers, let's say by 1 kilometer bank, you have a thriving industry here, let's say, supported by all kinds of people from what do we say, the administration, maybe. Again, here this is conjecture, obviously, right? But again, this is how things work, to political bosses and so on and so forth. But obviously, the people on the ground, let's say, they thrive for, they are out there for their survival anyway, right? Again, so we have a thriving industry out here, and people have tried to take steps, but obviously, unless you provide a worthwhile alternative to these people who are dependent upon this particular activity for their survival, even if you try to shut this down by some manner or the other, by bringing everyone together, let's say the enforcement agencies, the political bosses and so on and so forth, they will just mushroom somewhere else nearby, right? Unless you address the causes, you will never be able to address issues such as these, let's say, right? Again, so moving on, so we have a thriving industry here, and so all along this, the bank, let's say, is heavily polluted with heavy metals of all kinds now, right? The soils and sediments. So whenever there is rainfall, let's say, you are going to have the relevant leaching, or your contact of the relevant water with this soil, and then transport of these heavy metals downstream. And it looks like there are considerable cases with respect to health or even cancer, I believe, downstream, and people obviously filed some cases, and NGT was or is still looking into this particular aspect, as in how to remediate this and so on and so forth, right? So again, you also have considerable air levels of what do we say, high levels of air pollutants emitted in this area, typically dioxins. Again, that's remarkably toxic again, right? Again, there are many aspects. Again, I'll present some pictures in the next session, but I want to talk about a few aspects now. So in this kind of scenario, let's say, where you typically have, let's say, maybe a few feet of what do we say, soil, let's say, that's contaminated with different heavy metals and maybe some other compounds too, how would you go about it? Let's say, keep in mind that the area is considerable. So if not the entire 1 kilometer, at least a 0.25 kilometer stretch of the particular bank is remarkably polluted now, right? So 4 kilometer by 0.25 kilometer, that's considerable area, and then a few feet, that's considerable volumes of what do we say, soil now. So what are the options that people look at? So one particular person, let's say, even proposed, let's say, excavating the entire soil and then transporting it to a TSDF. What's a TSDF? So we come across this term called TSDF, that's unique to the case of India, right? That's a transportation, storage and disposal facility. This is obviously, this obviously caters to the needs of the hazardous waste generated in a particular state now, right? So TSDF. So when I refer to a TSDF, I am talking about a hazardous waste landfill, let's say, right? Obviously, it should be scientifically constructed and maintained. So typically in Indian context, though, we, to my knowledge anyway, as of now, we only have one per state, right? So we have one TSDF per state. So let's say if you are to excavate this entire, stretch of a few feet thick of soil, transport that to let's say the TSDF in Uttar Pradesh is only in Kanpur. So I think that's a few hundreds of kilometers away, maybe 300, 400, but I'll get the data again, or we'll look at the data, we'll crunch the numbers in greater detail in the next session. So if you want to do that, right, what are the relevant issues that you need to consider, let's say, right? So let's just look at those aspects. So we are talking about excavation now, right? So this is obviously one particular way that people look at, when considering remediating soils and sediments. So, excavation, let's say, right? So that's part one. So what are the aspects that I need to consider? Obviously, transportation costs, right? So there are many ideal case scenarios or ways to get things done, but obviously everything boils down to the resources available, right? And how feasible is it? And let's say again we are going to crunch the numbers. So typically for this case of Moradabad, we are going to look at the numbers later on. But transportation costs are something that you certainly need to look at. and obviously the excavation costs too, cost for excavating the soil, right, that is a major factor that we need to look into, right. And then what say, pollution during transportation, as in not the pollutants from the relevant vehicle, but let us say depending upon how well you cover this particular waste, let us say, or contain that within your particular vehicle, let us say, you can have what do we say, release of this particular soil, let us say, all along the relevant location, though that is a minor aspect. Depending upon the type of what do we say, contaminant, that can be an issue now, right. So these are some of the aspects obviously that we need to certainly consider now. So excavation, we can take that, there are two ways to then deal with the relevant waste. We can take that to what do we say, an off site, let us say, so ex situ location, and then treat it there. So right now we are not looking at treatment, keep in mind that excavation typically we take it to a different site and treat it. But let us say if you do not have the options to treat it, let us say, what can you do now? You can, let us say, dump it in a landfill, right. You can excavate it, transport it to a TSDF. But what is the issue here, let us say, at least in the Indian context that we are looking at? Keep in mind that we are talking about many what do we say, maybe 1000 meter cube or such. We will look at the relevant data again, right, huge volume of soil. So if you take out all this particular what do we say, contaminated soil and take it to that particular landfill, let us say, right, and again there are some regulations because it is not a you can't directly dump everything into a landfill. There are some thresholds or such. Because you do not want landfill to be a ticking time bomb, right. So there are some issues that need to be addressed there too before you dump it there, but we will reach or consider those aspects later. But for now, if you want to dump this huge volume of waste in this landfill, what is the issue here, right. So it's the issue is that landfill obviously limited space available. So if you dump this huge waste, huge volumes of waste in that particular landfill, you are obviously going to consume precious space, right, and you are going to have limited space available for all the hazardous waste that are generated throughout the year and for many years down the line from many of the industries in Uttar Pradesh, right. So these are the aspects that obviously we need to consider, let us say, when we are looking at excavation. There are some other aspects, but we will come back to that, right. Again we will crunch the numbers, but I want to do that in another context. So here let us say we came across something called a TSDF, right, or come across TSDF. TSDF or this hazardous waste landfill, right, landfill. So typically though, where do the waste that are generated in most of the Indian cities end up, let us say, most, let us say, not all, depending upon the kind of solid waste management programs that people have in place, right. You can have different types of or modes of disposal. But typically let us say, where do most of our municipal waste anyway end up in? Most people might not be aware of hazardous waste. They are relatively better maintained, let us say, but where do the municipal waste end up? They end up in some dumps outside the city, right. Typically let us say dumps as in there is just an open space that is far off from the city, or that would have caused less immediate what do we say adverse effects on the relevant population, and thus people just dump it there, or still used to, or even now people dump it there, let us say. And over time you have what do we say, if this is the site, let us say, and people are dumping waste, let us say, this is just a dump, keep in mind. So and now it is a mound, and it is no more economical or not feasible to dump more waste into this site, right. So they let this waste be. So what is going to happen in the meantime, right, what is going to happen here? So here now these particular organic compounds, let us say, do not have access to oxygen, right, they do not have access to oxygen here, let us say, right, they do not have access to oxygen. So all this particular what do we say organic matter, or even let us say plastics, they do not degrade though, right. But let us say other organic matter that we have, let us say in this municipal solid waste dump, let us say, what is going to happen, that is going to degrade, but degrade anaerobically, right. So anaerobic conditions, typically you will have acetic acid being formed among other acids, and again all this particular leachate, let us say, is going to travel or by gravity towards the subsurface, and now you are going to have contamination of soil, and depending upon the groundwater table, right? You can also have contamination of soil and groundwater, right? So this is a huge issue in the Indian context, right? And this is something that I think even the people at National Mission for Clean Ganga were grappling with. And again, most of the grade 2 or tier 2 towns, are facing such issues, where to put their waste and how to maintain that. But obviously, let's say if you just dump it, let's say, obviously you can look at recycling and you can look at composting, let's say, and so on and so forth, or energy recovery from the waste and so on. There are many other ways, some good, some not so good, at least in my opinion. But again, one aspect is that, you, in the absence of such measures, you need to store your waste, let's say, in some particular location, and that's going to be a landfill. But here typically we just have dumps here. And as you see, this leads to considerable issues down the line, because now you are going to have all this contaminated soil here, right? And this groundwater taking the contaminant downstream. So you have the leachate from this dump, right, contaminating all the soil here, and then the groundwater, they come in contact, and then the contaminants are now taken, downstream from that particular location, let's say, and you have again further contamination over a wider area now, right? So these are issues that you face with. So again, let's try to understand, let's say, how what a landfill should consist of, or what are the major aspects that a landfill should consist of, let's say. So obviously we are going to talk about hazardous waste landfill, because that's what we have been discussing in this particular case anyway. So let's look at that. So let's say you have hazardous waste, right? Hazardous wastes, right, or even municipal waste, but there's slightly different ways to dispose that, but we'll come back to that. So let's say you have hazardous waste that are generated by the industries every day, right? They can be, let's say, somebody paints, let's say, and you have the particular residue from the paints, again that's toxic, let's say, or even the what do we say, sludge from your primary settlement tank, let's say, from an industrial area, let's say a CETP is catering to the needs of an industrial area, and that particular primary sludge is going to be, what do we say, have high concentrations of heavy metals among other compounds, let's say, right? So all that is again classified as toxic or hazardous waste. So where do you, how do you get that, how do you dispose that? So you need to send that to a TSDF, let's say, if you are lacking in other options. So what are the relevant aspects that you need to look for? Obviously one aspect is that we need to collect this leachate or restrict the movement of this leachate, right? So in that context we come across impermeable layers, right? So there are different kinds of impermeable layers now. So let's say bentonite clay, let's say, and that's relatively well or with optimum compaction anyway, let's say, has hydraulic conductivity that is very low, right? Again, that's one aspect, but obviously even then, depending upon, let's say, alternate cycles of drying, let's say, and again being in contact with the moisture, let's say, that can develop cracks and so on. Again, depends upon the scenario or the site. So that's not the only option that we look at. So we also look at what do we say, HDPE layers, let's say, high density polyethylene, I believe, right? Or geomembranes and so on and so forth, right? So obviously let's just look at the relevant scenario here. Let's say these are my different mounts, let's say, from different days when hazardous waste has been piled up scientifically. We'll come back to this again, right? So if that's my particular case, let's say, what do I need now? Obviously I'll need impermeable layers, and so let's say I have a few thick HDPE membrane here, let's say, right? Yes, and below that I'll have, let's say, a few feet or centimeter thick, let's say, this is thick, 6 so on and so forth, and here a few feet. We'll look at a relevant cross section later on of an actual landfill. So this is the HDPE, let's say, and this, let's say, is your clay layer or bentonite clay layer, let's say. And what are the roles of these particular layers that we looked at? They are going to restrict the movement of any leachate, or leachate will be obviously generated, what do we say, to subsurface, let's say, right? So that's something that these are trying to do, right? So obviously, are we done here, or is that particular landfill good enough? Obviously not. Why is that? Because we are just restricting the movement of what do we say, the leachate generated to the subsurface. But obviously, we also do not want to have what do we say, a pile up of a head of leachate here. You don't want to have a considerable head of leachate develop here, because let us say there will be some punctures in this HDP either during operation or over time, let us say, right, and that can lead to what we say, leachate going through, and again hydraulic conductivity is less for clay, it is not 0. So then over time leachate will go through those. So what should I do? Obviously above this HDP layer I need to have a leachate collection system, right. We now have another term, we have a leachate collection layer or system, let us see, right. So let us say we have, this is the side view obviously, right, and these are the pipes, let us say perforated pipes, and you are going to coat them with what do we say, geomembrane or geo layer, let us say. Why is that? Because let us say you have perforated pipes, let us say, and if you do not coat them with this geotextile or such, let us say, your silt and such, let us say, can block these particular perforated pipes, let us say, and the leachate will not be collected. So you will have what can I say, your particular pipes, perforated pipes, to be coated with this particular geotextile, let us say, and here you will have relatively, let us say, gravel or such, let us say, and maybe sand layers, a few centimeters thick above this HDP membrane. Obviously, this particular leachate collection system, what will it have? It will have perforated pipes, let us say, it will have where through which the leachate is collected and pumped out. We will look at a few pictures, and we will also have, let us say, what do we say, geomembrane, let us say, not membrane, geotextile layer wrapped around these pipes, and up above and beneath we are going to have relatively more pervious what do we say, types of materials, let us say gravel, sand or such, depending upon the site obviously, right. And obviously you want to have this placed in such a way that your HDP beneath it is not damaged, right. So you need to choose your particular layers accordingly. So typically they will have some sand of a few centimeters thick, 30 centimeters and so on, and then gravel and so on and so forth. So let us say that is going to be the leachate collection system here, right. So all above this you are going to then dump waste. So a few centimeters thick leachate collection system, and then the HDP membrane, and then again a few centimeters thick clay layer, right. So any leachate that is formed, let us say, there will be a certain slope, right. These particular leachate collection systems will be at a slope either towards a central what do we say, collection pipe. For example, if this is the side view, that is what we have looked at. But if we look at the top view, let us say, and these are all the pipes that we have just looked at, these are all the pipes. So they can have a slope towards a central pipe, right, that goes to a sump, okay. So there again the sumps can be at the center or at the sides, typically the one at the side is better, but we will look at a particular example where it is a different case. Or let us say, all the pipes can be sloped towards a particular sump too, right, the different aspects. So but here what do we have? We have a leachate collection system, we have impermeable layers and semi-impermeable layers, right. So are we done with this? Not yet. Why is that? Because even if you have a leachate collection system, impermeable layer, semi-impermeable layer, even then leachate will go through or can go through, let us say, right, typically it will go through. So for this particular set of hazardous waste, we are going to have an extra layer of protection. And how are we going to do that? So we are going to have the same 3 layers here, as in what are we going to have? We are again going to have a leachate collection system, a second leachate collection system, a second leachate collection system, again with the pipes, perforated pipes and so on, right. So any leachate that can break through this particular layer will again be collected in this leachate collection system, and thus it is also called the leak detection system. So leak detection system, right, the secondary leachate collection system. And again beneath that you will have your HDP, the second HDP, and then again you will have your semi-impermeable layer with the clay again, right. So you have 2 layers of protection now, right. Again each one will consist of the leachate collection system, the HDP layer, and then your particular semi-impermeable or the clay layer, right. So again 2 particular what we say layers for the hazardous waste landfill. But if it is the municipal waste landfill, you are not required by law to have 2 such layers. You are fine if you have just 1 layer. But again, in India, for most municipal landfills, or they are not landfills, they are just dumps. So we do not have any of these particular leachate collection systems or the impermeable layers, right. So again, what's the issue here? The first one, obviously, typically, let's say if you look at the relevant data, which we are going to do in the next session, let's say, we will see that most of the leachate is pumped out from the first leachate collection system, and the second one, as we mentioned, serves as a leak detection system or a fail safe. Even if something goes through from the first particular leachate collection system and impermeable and impermeable layers, the second one should be able to capture that, right. Again, why is that? Obviously, why is it that we are going with 2 layers of protection here? Here obviously we have hazardous waste, right, remarkably toxic compounds and even carcinogens and so on. So obviously we are going in for that extra layer of protection, right. And how is this slope going to be looked at the slides? So typically, let's say all these layers are supposed to be taken up here, and there is a trench here and then here, and this trench is filled with particular material. Why is that required? Let's say typically if wind blows, let's say, you don't want to have this wind entrapping air underneath these pockets of impermeable layers, right. So again, to prevent both slippage, again you don't want this layer to slip, right, and also to prevent wind uplift or uplift by wind, you want to have a continuous trench throughout the perimeter or around the perimeter of your particular landfill, right. Again, we will come across this in greater detail. Again, I am talking about the landfill, but I want to look at a few pictures for now, okay. So here you see that I mean, this is not this was during the time of construction of a particular landfill. Again, this was in India, let's say. Again, because there are different stages, obviously it is not at pretty good or I would say it is not the ideal case for construction or an ideal example of construction. As you can see, the number of folds out here, obviously folds are a part of your particular landfill because you are going to have what do we say, expansion when the temperature is higher, and then contraction obviously depending upon the temperature. So folds are part and parcel, but obviously though you would like to limit such particular folds, let's say there are issues. And again, secondly though, one issue here in this particular landfill is that the relevant people did not cover this particular sides with the relevant what do we say layers like the HDPE layer and the clay layer too. So what happens is, let's say over time when they keep dumping soil, not soil, pardon me, the hazardous waste, that will be directly in contact with your this is the HDPE layer, pardon me. So I should mention that. So this is the landfill and this is the HDPE layer, this black what do we say, maybe 6 mm or 3 mm thick or 6 mm maybe, I guess, HDPE layer which is impermeable. So this is beneath your leachate collection system, and this is your leachate collection system. As you see, these are the different pipes, perforated pipes. As you can see, all these perforated pipes are taken towards a central collection pipe here, as you can see, and this is your leachate collection system, and beneath this, as in all this material here. And obviously, as you see, it is not homogeneous. Obviously, the picture was taken during rainfall, right, say, but again it is not homogeneous, as you can see, or again it was still under construction, right. So here you have the leachate collection system and the gravel and sand, but again the consistency and the homogeneity of the system is missing. And then rather than maintaining the slope such that all these layers can be taken, what do we say, up along the sides, they only took up the relevant HDPE membrane. So what are some of the issues in such a case? Obviously you have this HDPE layer now directly in contact to the sunlight, let's say, and typically that can lead to considerable decrease in the life of your particular HDPE layer, right. Typically, let's say instead of having a 150-year what do we say lifetime, it can end up with a lifetime of around 60 years. But landfills, we want them to be what do we say, fail safe for considerable numbers of years or decades, let's say, right. So that is one issue. And other than that, let's say when I am dumping the relevant soil, not soil again, hazardous waste, let's say, there can be punctures along the sides and that can lead to leakage, but again that might be minimal in this case because there is no standing head, right. Again, we will come back to this, I just wanted to introduce that. So another what do we say picture from another angle. So as you see, all these are the pipes, leachate collection system pipes. They are now collected in this single pipe, if I can say, and then they are transported to this sumps here. Here I see 2 sumps, one sump and second one. So, the first one is the sump that is connected to the upper or the first leachate collection system. The second one is the one that is connected to the secondary leachate collection system or the leak detection collection system. Obviously, that is underneath or beneath this particular set of layers. And here you obviously see the relevant perimeter, and here you see another almost full landfill here. I will call this cell 1 and this is cell 2, right. And this is just a picture of the relevant landfill. Let us see. Again, there are obvious issues, and I am going to discuss this further. But again, landfill, what are we concerned with? We want to capture the relevant leachate, right. Any leachate that is not captured in the first particular layer, we want to capture that in the second particular layer. Again, we pump that leachate out, right, and then we treat it, let us say, on site, or if there is no on site what do we say management system for the leachate, we are going to again have to take that XC2, but typically most landfills have on site leachate treatment systems, right. Again, these are aspects we are going to discuss in the next session, and again we are going to have some relevant data too to be able to better understand the relevant aspects, right. But since I am out of time, I will end today's session, and thank you.